All right, good afternoon, everybody. I'm Feynman. I'm currently a product manager working for Microsoft Azure, and I'm also maintainer of CNCF Notary Project and Ratify project. I have my co-speaker, Dahu from Alibaba Cloud.
Hello everyone, I'm Dahu. I come from Alibaba Cloud, and I'm focused on the container security, and I'm also a contributor for Notary Project.
All right. I actually brought some very nice beanies, our project swags, for everybody who have questions after our speech. Also, I think the room is relatively large and empty, so if you want to sit in front of and get closer to our screen, to the stage, that would be super appreciated. All right. Today, we're gonna share the real-world problems and the challenges in software supply chain. And we will introduce open source projects and framework like SLSA, Ratify, Notary Project. We'll use these projects to demonstrate how to secure Kubernetes deployment and AI workloads in the real-world examples. And Dahu will also demonstrate how to deploy a trusted AI workloads to Kubernetes cluster with SLSA framework and Ratify. All right. I believe most of you have security teams in your companies, right? And those security guys have been really annoying because they constantly ask you to follow in their security best practice and guidance. So in my company, I have a security manager, Dahu. Hey, Dahu.
Hey, Feynman. There is some security best practice and checklist in our company. Could you please let your team obey this checklist?
Let me take a look. All right, this is a good guidance. It's a long list. I will definitely bring this to our team and make sure our team to follow the best practice. Let's take that.
Great. And could you please also let your team apply the security system and controls to your development lifecycle and workflow and pipelines?
Yes. I will definitely bring this to our team's meeting, and I want to make things really actionable in our daily development lifecycle. I will emphasize this in our team's meeting. Don't worry, bro. Trust us. Trust me.
Okay, I will trust you for.
So actually, our dependencies and software are acquired from GitHub, the largest open source software in the world, right? So everything on GitHub, they are open source. They are transparent. So trust us.
Hey, Feynman. Our detector scan, there's 5 critical vulnerabilities and instances in your product environment and running image. That's very risky. I thought you have said you have deployed this security control in your environment. Is that right?
Yes, we did. We enforced several supply chain enforcement and policies in our CI/CD pipelines. Every time when we download software from open source package managers and GitHub container registry, we always validate those things before we download those public resources. I don't know why this happened again.
Did you check this open source package and dependency from the open source world? And did you verify this attestation?
To be honest, we only validate the supply chain metadata like signatures and SBOM when we download software from GitHub and from Docker Hub. But when our customers, when they deploy their images and AI workloads to their Kubernetes clusters, I think we don't have such enforcement policies so far. So that's the thing. I want to look for more solutions today. So Dahu, would you want to share more practice today?
But why this security instance still happen again?
I don't know, to be honest. But there should be something we can follow, like the very promising SLSA framework, the Ratify verification engine. That's the thing we're gonna take a deeper look today, right? So as you all know that nowadays, almost every developer platforms and source control systems, they all produce supply chain metadata, such as attestations, S-bonds, signatures, right? I think generating those supply chain metadata in the container registry on GitHub, that is really easy. I think consumers and developers can also validate those things when they download the software from public source and acquire those images from public registries. This is the easy thing. But the hard thing is, when you try to validate those images and enforce only trusted images and workloads can be deployed to your Kubernetes cluster, to your production environment, that's the hard thing. We all know that there are some admission controllers and a lot of standards in the industry, like SLSA framework. And at Microsoft, we also have our container secure supply chain framework. There are a lot of standards in the industry already. But however, the industry is dynamically changed. We always have security incidents happen almost every day, again and again. That is really annoying, right? That is why my security manager always pushed me to upgrade our dependencies to make sure our images are signed by the trusted identities, right? I believe most of you have been annoyed by such kind of best practice, right? So today, we're gonna take a look at how can we enforce those really long list, the checklist in our production environment, and make sure there's only compliant and trusted workloads can be deployed to Kubernetes cluster. So this is how SLSA framework defines the threats in different phrases. So when we talking about supply chain security, we always talk about the full life cycle, the full development life cycle from build, from the source to build, to distribution, and eventually to the consumer through deployment, right? Looking back, looking at the several security incidents in the past few years, we have seen there were a lot of security incidents in the build phase, in the source phase. I still remember last year, the XZ utils. There's a developer injected a backdoor into the XZ util component in open source project, and there are a lot of downstream projects that rely on XUtil, and we have seen a lot of companies and downstream open source projects upgrade their dependencies immediately. Every time when there's a security incident happened, that is really urgent to everybody, right? We have been so annoying about this problem for a long time. So can you help me switch? XUtil is not a single problem, and we have seen a lot of security incidents, vulnerabilities, and compromise changes in other vendors like SolarWinds, CodeCarve, and a lot of enterprises, even we as Microsoft, we are facing very challenging security problems and vulnerable malicious software from those external resources. I want to see how many of you have been heard or used SLSA framework in your development lifecycle. Okay, we have 1, 2, 3, 4, 5. Okay, we have so many people. So I think I don't need to spend too much time on explaining what is SLSA, right? Okay, SLSA is not something new. It has been released and contributed to OpenSSF Foundation, I think 2 or 3 years ago. And previously, SLSA framework focused more on the build side. They have the build track available in the SLSA community. They have a bunch of incremental levels defined for how to secure build phase with different open source tools and services. Back in June, early June, SLSA community, they introduced source track in the community. And this is available in SLSA 1.2 RC1 release. So today, I'm going to share more about what's new in SLSA framework and how can we, from Notary Project and Ratify, integrate with SLSA to enforce only compliant images, and only compliant with SLSA level 3 images can be deployed to Kubernetes cluster. So here, this is how we add Notary Project, the signing tool, and the Ratify, the verification engine, to work with SLSA framework. There's a tool called SLSA source action, and there's another tool called SLSA tool that can mapping the rule sets that we defined in the source control system, such as GitHub, GitLab. So there are certain rules that we can define for different levels. So for SLSA level 1, we can make sure the development team, they should use a compliant source control system, and they should use the revisions and ensure all of the history, commit history, should be preserved in their source control system. And every commit should have a verified and can be identified by their URL. And also for level 2, we should have full control over those protected branches and tags. I think for security incidents, that indicates not only vulnerabilities, we still have seen there are attacking behaviors like unintentional compromise or accidental deletion of the protected tags or branches, or malicious injection into your main branch, right? So there are a lot of unsecure behaviors that may happen in your production environment, in your branches, in your tags. But through SLSA level 2, you can enable and enforce every Git commit is auditable, and they should have a way to track who contribute what change to your branch, to your tags. So level 2, basically it wants to make sure the continuity for your Git revisions and make sure everything is auditable in your repository. In terms of level 3, there's a concept called source provenance. So basically, we can use a provenance file to make sure the code that you produced and the image that you built is trusted and is also trusted, is from the trusted identity. So here, a provenance is more like a signed receipt. That includes what's inside your packages, what's inside in your container images, who built that, which platform that you used to build your container images, and which CI/CD pipeline that you used, when did you build that? All of those very detailed metadata information and also the identity information will be included in the provenance, and the provenance itself will be signed by the identity who produced the software. So level 3 is much high level, has more enforcement on the security policies. And level 4, that means you will need to enable two-party reviews. I'm not sure how many of you are working in open source projects. Can you please raise your hand? Okay, 1, 2, 3, 4. Okay, we have so many people. So if you're working on open source, I think there's a very common pattern that you will need at least 2 approvals from 2 different companies or organizations to review and approve those changes before you merge that, right? This is also another way to prevent any unintentional change or any malicious behaviors to your protected branch. All right, today we're gonna have 2 samples. The first sample will be an image built from a repository that is compliant with SLSA level 1. This image will be blocked, and we will have another image that is compliant with SLSA level 3. That image will be admitted. Can you help switch? Okay, before we dive into, we're gonna have a quick introduction to Notary Project and Ratify. So Notary Project, this is a PKI standard-based signing and verification project. We offer CLI tools, libraries, and standard specifications for developers and security administrators. So basically, Notary Project can help you to sign and verify your container images, arbitrary files, and any blob files in your local file system, in your container registry. And Notary Project can also work with Ratify in air-gapped environment. This is something that we have been investing for a long time, and we have been looking for more scenarios related to how to enable enterprise customers to use Notary Project and Ratify in air-gapped environment or on-premise environment. So today, I'm really proud to say we have a lot of cloud providers who build their own plugins based on Notary Project specifications and standard. Now we have Alibaba Cloud, Microsoft, AWS, Ratify, and HashiCorp. They built a very rich ecosystem based on Notary Project standard. Meanwhile, we also have a lot of admission controller as the validation part to help the ecosystem to validate Notary Project signatures. The projects include Kyverno, Ratify, which is the project we're gonna demonstrate it later, and also Canacel, not sure if you heard that, admission controller. So those three admission webhook admission controller projects today support validating Notary Project signature. We also have a very easy to use CLI tool called Notation. This one is a CLI tool that you can easily integrate with your CI/CD pipelines like GitHub or Azure DevOps or GitLab. This is the way that you can interact with the Notation CLI tools. Next slide, please. So in terms of Ratify, this is a new project, recently joined Notary Project as a sub-project. Ratify basically provides a very wide range of the validation capabilities to Notary Project, also to the entire supply chain ecosystem. So Ratify, originally it was a sandbox project and joined the Notary Project back in June. Right now, Ratify is also a verification framework that customers and vendors can extend Ratify by developing their own plugins. Last month, Alibaba Cloud, their security team contributed a new plugin called SLSA Verifier to Ratify ecosystem. And this is the thing that we're gonna demonstrate it later. So Ratify has 4 components. It includes the policy. This can work with policy engine such as OPA Keeper or Kyverno. Verifier, that means you can validate different supply chain metadata, including SBONs, signatures, vulnerability scanning report, and provenance attestations. The community ecosystem is still growing, and if you have any requirements or if you are a vendor that you want to extend the supply chain security verification, feel free to reach out to me and we can talk about more ecosystem collaboration. Next slide. Today, Notary Project and Ratify are super extensible, as just I shared. And it can work with the major cloud providers and also the security vendors, such as AWS, Azure, Alibaba Cloud, Ratify, and HashiCorp. And also, it is registry agnostic. That means you can use Notary Project and Ratify with any kinds of OCI registries. And I think most of the OCI registries today, they're compatible with OCI standard. That means they should be able to work with Notation and Ratify. Next slide. So where you can use Ratify? One of the typical scenarios is it can be used as an admission controller, and it works with Gatekeeper, the OPA Gatekeeper, and the Ratify will be serving as an external data provider for Gatekeeper. And every time when there's a pod create request coming into Kubernetes API server, the Gatekeeper will intercept the request and analyze whether this image is compliant with the policies, the rules that we defined for Ratify for your container image. And the Ratify will be checking the constraint templates that we defined in Gatekeeper and as admission controller to whether approve your image or deny your deployment request in Kubernetes cluster. Ratify can also work with runtime such as Containerd or Docker Daemon. And also Ratify can be used as a CLI in your CI/CD pipelines to validate those supply chain metadata. Next slide. So here's how Ratify and Notary Project working end-to-end in this workflow. So basically, when developers build their source into an image or Helm chart. You can use notation or cosine to sign your image and use scanning tool like Trivi or Scrape to scan your image vulnerabilities and generate reports. And also use SLSA source track, the source tool, to generate the provenance. And then you're gonna use auras to attach those supply chain metadata with your container images or your artifacts. Everything will be associated and pushed together to the container registry. So once you have the images pushed to the container registry, you should be able to deploy those images or those artifacts from the registry. So at this time, when you run kubectl, when you want to run kubectl to run this pod in Kubernetes cluster, this is where Ratify and Gatekeeper come in. They will check the security policies that you defined in your Kubernetes cluster and for your cloud native workloads. So next slide. So here, Ratify work together with OPA Gatekeeper as an external data provider, and it will intercept the create request. And let's see this in action. We're gonna have a lab demo that will be conducted by Dahu, and Dahu will walk through the end-to-end scenario and also what we achieved with the SLSA verifier plugin with Ratify and SLSA. So next slide, and I think
Okay,
Dahu is your turn.
thank you, Feynman. Okay, before the demo, we will make a brief introduction, and we will deploying AI agent workflow workload in the Kubernetes cluster. And with a twist, we will secure the supply chain with the SLSA source trunk. And every time when developer push a commit to our demo project, it will trigger a pre-configured SLSA source action. And in that pipeline, it will run the source tool to check the commit's SLSA level and generate the signed attestation, which including a VSA and a provenance attestation. And both of them can be signed with 6-door or Notary. In this demo, we use a 6-door for example. And then, as the maintainer can attach the attestation to the resulting image via the ORAS. And in the deployment time, we use Gatekeeper and Ratify to enforce the trust. And then we apply a SLSA Verify plugin and create the policy. Then in the admission time, the Ratify will verify the things like verify ID, the resource URL, and the SLSA level. At the bottom line, only the agent image with the trust and the valid attestation can be deployed in the cluster. Okay, this is our demo. And then in our demo, we will show two things. The first thing is how to get an open source project all the way to comply with SLSA level 3. And then, as Feynman mentioned, we will deploy the two agent image. One of them is SLSA level 1, and the other is SLSA level 3. And we will watch in real time as Gatekeeper and Ratify will block the unsecure one and deploy the trust one. So let's begin. Firstly, there is a lightweight kind cluster, and we have deployed Gatekeeper, Ratify, and K-Agent. K-Agent is our AI workflow platform. And then we deploy a Gatekeeper, Ratify constraint template. Okay, here we meet K-Agent. K-Agent has a built-in UI and has some default AI agent tools. Here's the fun part. The K-Agent fully supports the BYO, bring your own agent image, so that you can just input the image URL in the agent CRD. Okay, then we deployed a Ratify constraint. It's a Gatekeeper constraint. It will tell the system in the K-Agent namespace only the image that pass all of our SLSA policy can be deployed in the cluster. If it doesn't, just deny it. Okay, the Ratify constraint is ready. Here is the four distinct SLSA level Feynman mentioned before. And here's the source tool. In their document, it lists all of the checking items that will run when every commit push to the main branch. For example, the protected tag and branch. And how to hit the SLSA level 3 in your open source project is easy. Just go to the GitHub configuration page and create two root sites. This is one of them. Just enable the restrict update, deletion, and forbidden the false push for all of the tags. And there is another root site. It works on the main branch, and the same deal, just no deletion and no false push. Here we create a SLSA action. In our demo project, we use SLSA action, and so every commit that merge into our main branch will run this too, and check the commit SLSA level and generate the signed attestation. Let's check it out. This is our latest commit job. You can see the action page is hit the SLSA level 3. And you can download the provenance to your local file system. When decode the VSA, you can find some information, such as the resource URL, the verified level, and the verified ID. And this information will be used in the ratify in the admission time. You can download the demo image from the GitHub. For the project maintainer, you can use the ORAS to attach the attestation. And then you can use ORAS Discover to inspect the attached attestations manifest. Okay, then we apply a SLSA Verify plugin. Here we define the policy rule. We define the expected verify level to level 2. That means only the agent image that comply with SLSA source level 2 or higher can deploy in the cluster. And the verify ID and the resource URL. Okay, the plugin is created. Here is a test time. Firstly, we will deploy agent image with the SLSA level 1. And then we plan to check if ratify can block it. After some seconds, we can see the ratify has blocked it. It works as designed. And you can see the admission log. In the ratify pod log, you can see our deployed agent image SLSA level is 1, and we require level 2. And we can continue with our security bar. Here we update the SLSA level from 2 to 3. And that means that only the agent image that's compliant with level 3 can be deployed into the cluster. And so we can just update our agent image ID. This is our latest commit, and it's the image that complies with level 3. And let's check if it can be deployed in our cluster. Okay, we refresh the agent deployment. And after some time, you can see the agent pod is running, and the ratify admitted it. You can double check it from the ratify log, and it's successful. Okay, back to the K-agent UI, you can see our VYO agent is running. Let's check it. We can input some command to LLM. agent is thinking. So we just waste some time. Okay, the LLM is response. Okay, our BYO agent is running. Okay, that's our demo. We have shown how to ensure end-to-end source integrity for the AI workloads. And here is some useful links. And we also provide a complete quick start document in the demo project. You can check it out if you are interested.
All right, thanks, Dahu. Thank you, everyone. I think we are running out of time. But oh, you have a question? I think we are out of time, and we will running a project booth in the project pavilion from 4 to 7 p.m. So I think we can continue the discussion maybe offline. Yeah, thank you so much, because there are other people waiting outside. Yeah. Sorry? Yeah, 47. Yeah, in the project pavilion, in the showcase, solution showcase, we can still talk more about the signing and the verification story. Yeah, today we are running a bit of time, and I still have some swags, the project business that I reserved. So if you want to talk more about Notary Project, Ratify, and SLSA, I'll wait for all of you at the project booth, Notary Project booth, from 4 p.m. to 7. Okay? Thank you, everyone.
Thank you.